Okay, the complex number u is given by u equals to 7 plus 4i over 3 minus 2i. Number 1, express u in form of x plus iy, where x and y are real. Number 2, sketch an Argand diagram showing the point representing the complex number u. Show on the same diagram the locus of the complex number z such that z minus u equals to 2, and then find the greatest value of Argand z, okay, for the points on this locus. Okay, let's do this. Okay, first of all, when you have a question like this, complex number with the u is given by 7 plus 4i over 3 minus 2i. So what you have to do is you have to times the conjugate of the denominator so that I can rationalize this this complex number. Do this. Okay, have a look. So u is given by 7 plus 4i over 3 minus 2i. So multiply this by the conjugate of 3 minus 2i, which is 3 plus 2i, and then times the same thing to the numerator. So from there we get 21 plus 14i plus 12i plus 8i square over 3 times 3 9 plus 6i minus 6i minus 4i square. So let's simplify this. You get 21 plus 8, and since I square is -1, sub that, then plus 14 and 12 is 26i over 9 minus 4, and I square is -1. So if I simplify this, I get 21 minus 8 plus 26i over 9 minus 4 times -1 is plus 4, and the answer is 21 minus 8 is 13 plus 26i over 13. Let's simplify this. 13 over 13 plus 26i over 13, which is 1 plus 2i. Okay, so as the question requires us to find in x and y where x and y are real, so we have got that where x equals to 1 and y equals to 2. Okay, for part 2, sketch an Argand diagram showing the points representing the complex number u. Show on the same diagram the locus of the complex number z such that z minus u equals to 2 plus 2i. Okay, 1 plus 2. Z minus u equals to 2, where u equals to 1 plus 2i, u equals to 1 plus I. So therefore, so let's draw this. What do I have? So okay, positive 1, that's your real axis, and that's the imaginary axis. So 1 on the real axis and 2 is on the imaginary axis. So let's say that's 1, so that's 2, that's 3, that's 4. Okay, approximately. So that's 1, oops, that's 1 and 2i, so it should be up here. So that's 1 and then 2. Okay, so that's 1 and your imaginary value will be 2. Okay, so once that's drawn, now let's draw the locus which has a radius of 2, so therefore it's a circle. So radius of 2, so that's 1 and that's -1. So if that's 2, so that should be positive 2, and then you add another 2 here, so that's 2 and then 3. Okay, approximately. So now let's draw. So you have a circle, one here, and then another one here, another dot here, and another dot here. So if I Okay, if I link all the points or join all the points, you should get a circle. Okay, you should get a circle somewhat like this, okay. Oops, should not be going down, so should get a circle okay, that's better. Okay, a circle something like that with the radius 2. Okay, and that is 2, the radius is 2. Likewise over here. Now the question, okay, now that's done. Show on the same diagram the locus of complex number z such that z minus u equals to 2. Okay, so that's the locus. So this is z, label that. And find the greatest value of argument z for points on this locus. The greatest value of argument z. Okay, this is from the origin, and that's one line that touches the locus, and the other line that touches the locus will be this line here. So since the question requires us to find for part 3 the greatest value of argument z, okay, for the points on the locus, for the points on this locus, so we have to consider where do I have to draw the line, or which point on the locus that will give us the greatest argument z, okay, or the greatest angle in this case, okay, the greatest angle. So certainly this line, okay, will give us the greatest angle, which is not this, the x-axis, but the one over here. So let's say I label this maybe just a. So that is the line that will give us the greatest argument, which is this angle here. Okay, so that's the angle that I have to find. Okay, to find that angle, since that's right angle, so if I draw a straight line, so that should be a right angle since it's a tangent, and that's a right angle. So again I can draw a congruent triangle, two congruent triangles. So you have one over there like that, and then you have another one like that. Okay, so there you go. So it's right angle over here, sorry. Okay, so it should be right angle over here and right angle over here. Yeah. Okay, my diagram is not accurate, but I hope you get the idea. So this part here, which is this line, is basically radius, so that should be 2. And since this line is 1, okay, which is 1, this must be 1. Why? Because it's a tangent and they are meeting at the same point, which is the circle, center of circle. So this is exactly congruent. So this is congruent to this line is congruent to this line. So basically these two triangles A and B are congruent. Okay, so I have to find the greatest angle, which is from here all the way here. So to find that, okay, I have to find what is this angle. I have to find what is this angle. If I can find that angle, I just have to times it by 2 to find what is the greatest argument z. Okay, so let's do that. So this angle, which is same as this one, is opposite over adjacent. Okay, tangent, arctangent, opposite over adjacent. Okay, so this will give us the angle, let's say that's alpha. Okay, it will give us the angle alpha, and if you multiply this by 2, okay, because they are congruent, and that should be your greatest value. So let's find that. So you get, okay, arctangent 2 over 1 1 point, so alpha is 1.07149, and times it by 2 give me, okay, multiply this by 2 times it by 2, you get 212,143. Therefore the greatest value of argument z for the points on the locus is 2.214 radian.